Hello everyone, welcome back. This is video is intended for my calculus class. I believe it's section 3.3 for us. This is just the beginning part of curve sketching where we are doing increasing and decreasing intervals. So hopefully you remember from pre-calc that I've got a graph here. It's actually a cubic graph. That you remember from pre-calc that this part of the graph is increasing, this part of the graph is decreasing, and then this part of the graph is increasing again. We will show using calculus on how to determine increasing and decreasing intervals by finding critical values. So let's look at some of the steps that go with it. So these are the steps we want to find the critical values, and that's taking the derivative and setting it equal to 0 and solving for x. We're going to set up intervals using the critical values, making a number line. Step 3, we're going to pick test values that go into the derivative. Now that's the important part here. We got to make sure that we evaluate these into the derivative. Okay. We're going to label the intervals, increasing or decreasing, depending upon what we did in step 3. And then we apply the first derivative test. Now that is basically telling us in layman's terms here, you can read these, but that tells us pretty much that if a graph goes from increasing to decreasing, we're going to have a max at that point. Or if we go from decreasing to increasing, we're going to have a min at that point. And that is pretty much what the first derivative test is telling us. Then to actually find the extrema, we're going to plug the x values back into the original function and get the max or the min that go with it. So what I'm going to show you here is we're going to do this first example here. I've got a very basic one to start, and that is x squared. Okay, now we all know, at least I hope we all know what x squared looks like. I'm just going to draw a real quick graph here. We all know that it is a parabola right at the origin. And we know that already there's a minimum right here at x equals 0. Okay, and we can see just by knowing our basics here that this is decreasing and then this is increasing. So we want to use calculus to show this. Alright, so what I'm going to do here is starts all by finding the derivative. So we know that the derivative just with the power rule is going to be 2x. And then we're going to find the critical values. So we're going to take 2x and we're going to set it equal to 0, solve for x. So therefore, just by dividing by 2, we know that x is 0. Alright, so now we're going to set up a number line. Okay, so I'm going to set up a number line. I'll put my critical value at 0 right here. And we are going to pick test values for the derivative. Alright, so I'm going to pick something pretty easy here. We're going to go f prime of -1. And f prime of 1. I picked a number that was less than 0, and I picked a number that was bigger than 0. So if I plug in -1 to the derivative, I'm going to get -2. I really don't care what the number is. I really care, though, if it's positive or negative. So if I plug in -1, I'm going to get a negative answer. Okay, so by getting a negative answer, that tells me that the function is decreasing. Then I plug in 1, so 2 times 1 is 2. That's a positive answer, so I'm going to get a positive answer. That tells me I'm increasing, and as you can see, that's what's matching our graph that we already know of ahead of time. So because I go from decreasing to increasing, I know that I have a minimum at 0. So one of the things we have to do is we have to make our intervals. So according to our number line, everything from the left up to 0 means we're going to go from -infinity to 0, and we know we are decreasing on that interval. Then we also know that from 0 to infinity, we are increasing on that interval. And again, our first derivative test tells us that if we go from decreasing to increasing, that means we are going to have a minimum at 0 comma something. Now one thing you have to remember, that anytime you need a y value, you go back to the original function. So I'm going to plug 0 into the original function and I get 0. So that was one we actually knew ahead of time, but I showed the calculus on increasing and decreasing and getting the minimum. Let's look at a different one here. We'll try another one. and I believe it's right up here. We've got x cubed minus 3x. Alright, so let's do the exact same thing. I'm going to find the derivative. Okay, so the derivative, f prime, is equal to 3x squared minus 3. And then I'm told I got to find the critical values. So I got to take 3x squared minus 3, and I'm going to set it equal to 0. I'm going to factor out a 3, get x squared minus 1. So I know that that factors to x plus 1 and x minus 1. So I know that my critical values are at x equals -1 and +1. Alright, so now what I want to do is I want to set up my number line, and I'm going to put -1 and +1, and I'm going to pick test values now for the derivative. Okay, so I'm going to pick f prime of, I'm just going to say -5, f prime of 0. 0 is always one you want to pick if you can, because that's easy to plug in. And f prime of, I'll just pick something like 10. Alright, so I'm going to plug -5 into the derivative. And again, don't really care what the exact number is, I just want to know if it's positive or negative. So if I plug -5 in there, I square that, that's going to be 25 times 3. That's a big number minus a little bit of 3. So that's going to be positive. So being positive tells me it's increasing. And then I'm going to plug in 0. That's an easy one to plug in. Plug in 0 is going to make that 0. Then I have -3. That's going to make it negative. And that means I'm going to be decreasing. And then I try 10. 10 squared is 100 times 300 minus. That's going to be positive. And I'm back to increasing. Okay. So now I know this graph. Now, ahead of time, I know a cubic kind of looks like that. It goes increasing to decreasing to back to increasing. So my intervals. Now, one thing I have to make sure is I label my intervals here. I know that from -infinity to -1, I am increasing. I know that between -1 and 1, I'm decreasing. And I know that from 1 to infinity, I'm back to increasing. And now the first derivative test tells me, since I'm going from increasing to decreasing, that I'm going to have a max at -1 comma something, and that from decreasing to increasing, that means I'm going to have a min at 1 comma something. And I can use my calculator, or I got to make sure though that anytime I need a y value, I got to go back to the original function. Alright, so if I plug in -1, and -1 cubed is going to be -1, and then -3 times negative, so I'm going to have -1, so -1 and then +3, so I know I'm going to have 2 is my y value for that. And then plugging in 1, that's going to wind up being 1 minus 3, and I'm going to have -2. Now I bet you if we check now, if we go to our calculator and we plug this in, that's a great way of checking, is we will see that the function goes increasing to decreasing and then back to increasing, and this max and this min will be happening at -1, 2 and 1, -2. And let's do one more just to make sure everybody's on the same page here. So I believe we have here f of x is equal to x cubed minus 3/2 x squared. Alright, so let's find the derivative. So the derivative is going to be 3x squared and then minus 3x. We're going to take the derivative. We're going to set it equal to 0. And I'm going to take out a 3x, and I'll have x minus 1. That means I'm going to have critical values at x equals 0 and 1. So I make a number line, and I will put on the number line 0 and 1. And let's pick some test values. So I'm going to go f prime of -5, f prime of a half. And let's go f prime of, I don't know, something big. Let's go 20. All right, so we're going to plug these in. They got to go into the derivative. All right, so we're going to wind up here with 25, 75 minus, so this is going to be a positive number. So that means we are increasing. All right, plug in 0.5. So 0.5, and we square it times 3 minus, that's going to be a negative number when we plug that in. So that's going to be decreasing. And then we plug in 20 and we square it and we subtract. We're going to see that that's another positive number. And again, if you're not doing it in your head and you want to plug it in your calculator, go ahead. It's going to show you the actual answer. And then so now we know that our intervals go from negative infinity to 0. And on that interval, we are increasing. Our next interval goes from 0 to 1. Means we're decreasing. And our last interval from 1 to infinity is back to increasing. Okay, so then we know, to finish this up, that we are going to use our critical values. We know that we're going from increasing to decreasing at 0, so we know we're going to have a max at 0 comma something, and we need to take that 0 and go back to the original function, and we'll have, by plugging in 0, we're going to have 0, 0. And we know that on our number line here, we go from decreasing to increasing, so that's going to be a minimum happening at 1 comma something. And we go back up here to our original, and we know that when we plug in 1, we essentially have 1 minus 1.5, which is negative, what happened there? Which is negative 0.5, so negative 1/2. And that's how you apply calculus to figure out increasing and decreasing intervals. So if you have any questions, leave it in the comments below, and I appreciate you taking the time out of your day to watch it.